Hello, welcome back to this random table where I fix stuff. This is a Philco Model 81, Philco Junior. So this is from 1933. This is a 4-tube super heterodyne set. And kind of the interesting thing about this is that it doesn't use any multifunction tubes. It only uses single function, triode, pentode, rectifier, stuff like that. There's no combined functionality of these tubes, so it's kind of interesting how they got it down to only 4 tubes without using like mixer oscillators or anything. Cabinet's not in terrible shape. There is a little bit of veneer missing here and there. A piece of veneer is peeling off the back here, but it's still pretty solid. It's not like really falling apart. On the back, I think this is the absolute worst power cord I have ever seen. It's like someone's antenna is tangled up in it. It used to be an antenna. It's no longer actually attached to anything. I think there's more bare wire in this cord than insulated wire. Antenna wire out of the way. You can see there's whole areas where it's just bare, so no chance of plugging this one in without changing this first. Falling off in my hand. So you've got a nice globe type 80 tube. I believe this uses two 77s or 75s. I think they're 77s, I think. 41 output tube, and yeah, that's it. 4 tubes. 80, I think the two 77s and the 41's probably back there. Interestingly, it does have a pretty large power transformer. Interesting they use such a large power transformer for only 4 tubes. It looks like more like, this is about the same size as I've seen in like 8-tube RCA radios. It looks like we got 2, probably, these are probably dry electrolytics. Oh, they could be wet ones, not sure. So right around this time I think is when they were changing between dry and wet. But anyway, they'll have to be changed. I'm sure that there's no chance that those are any good. So the first thing to do is going to be get this out of the cabinet so we can replace these capacitors and replace this cord before we go any further. There's really nothing to note on the cabinet. Like I said, it is pretty solid. Just a few veneer pieces that are loose and missing, and some of the finishes missing. That's really not a big deal. I think I'm going to take the speaker out with it because there is no plug. The speaker is hardwired in. And if you look closely, you can see there's some tape on here where someone's probably taken it out and then just spliced it back in before. So I'll probably take the speaker out with the chassis, and then we can bench test it out of the cabinet. So let me do that. So I got the chassis and the speaker out. The speaker doesn't look too hot though. You can see there's a piece torn here and here. And if you look carefully, you can see it's starting to separate from the spider right around there. If I turn this on its side, you can actually see, if I shade here, there's actually light coming in down around there. So I'm going to see if I can put some glue on that to hold that in place so it doesn't deteriorate further. I have moved it a little bit. It doesn't sound like it's rubbing, so hopefully we can just get away with gluing it the way that it is, and hopefully that'll be okay. Alright, so there's some emergency speaker repair here. No, it's not the right kind of glue, but it'll still work. So the way that these speakers work is it's not like the modern speakers where there's a rippled foam or like rippled paper around the outside of the voice coil, and that's the spider. This one has the spider in the middle, so this middle part is bolted down and the speaker is glued here, and then that is what keeps the voice coil centered over the magnet. And now that I fixed this, you can see it moves, no scratching, so that should be okay. You do want to have a rigid connection here. That's the way it's supposed to be. And then these little legs here are what provide the spring action. You can see when I push on it, they spring it back to where it's supposed to be. So I think that will work. Obviously, we won't know for 100% sure until we try it out, but definitely has, you know, a good amount of travel without rubbing, so I think that should be okay. Take a look at the chassis here. This is probably the 41, the two either 77s, the 80. I guess I have cleaned that up. I wanted to take a look at it because on these Globe 80s, I had an RCA a radial 17 that came with the original Globe 80 in it, and when you looked at it, so if you look in there, you can see the filaments, and you see the white coating on the filament. That's the oxide layer that is required to enhance emissions. Well, in an RCA that I had, all that oxide had fallen off and was all laying in the bottom of the tube. So I want to get a look at this one to see if the oxide was still there, and yes, it is. Now, of course, that doesn't guarantee that the tube is good, but the oxide falling off and laying in the bottom of the tube pretty much guarantees that the tube is bad. So I just wanted to take a look at that, and it should be good enough for us to try it out. We'll see how it performs. Take a look at the underside of the chassis. These two capacitors I definitely want to replace before powering this up because almost guaranteed these are dried out. I checked the schematic. This is a 4 and an 8 microfarad. And then the field coil, pick this up. The field coil on the back here is in between them to provide extra filtering. So we'll flip this up and go look at the bottom of it. Down here on the bottom, it looks like someone has already replaced at least one of those, but this is probably dried out again, so I'll probably replace that. It looks like they did cut the old one out of circuit, which is good. A lot of times when people replace the old capacitors, just leave the old one in circuit and just tack the new one across it, but it doesn't help if the old one shorts out. But this time they actually cut the solder tab off, I guess, and they just wired it into this one. But I will replace this one as well because who knows how old that is. Could be good. Could be, like, if it's from the 50s, it theoretically could be good, but I'm not sure if it's worth it. I'll probably just replace it while I'm in here since I have to replace another one anyway. So do that, and when we replace this cord, and then hopefully we can do a power up test. So on second thought, it actually looks like all the original paper capacitors are inside these Bakelite blocks here. Someone's just bridged one across there. I guess one of those in there failed. Now, I think I mentioned this before, but I've heard that, I've never experienced myself, but I've heard that if these capacitors short in here, it's very common for it to blow the side of the block out, and then your block is ruined. So I think I might just go ahead and replace all of these anyway. There would only be probably 2 per block. I can't imagine how they would fit more than that in there because there's only 3 terminals. So I guess I'll just replace all those 2. There's not that many, there's only 4 blocks. So while I'm in here doing the electrolytics, I'll just go ahead and replace these as well, just so that I don't have to worry about trying to fix these blocks if they happen to explode. So normally what I like to do is power up these radios first and make sure that, you know, all the coils are going to work and everything, but in this one I don't see a safe way to do that without risking damaging these blocks. So just go ahead and replace them. There's not that many capacitors, so if we try that and something is wrong with one of the coils, that's not a huge loss. So I'll just go ahead and do that, and hopefully it'll work after that. Okay, so I rebuilt all those blocks and made quite a mess, as you can see. The electrolytic capacitors, I put both of them right down here. They both connect to this point, and this point is the center tap off the power transformer. So the way that this works is ground, or the chassis is not connected directly to the central tap of the power transformer. It's actually connected, so you can see ground comes in here, goes through this resistor, and then into that center tap. And I believe the reasoning for that is to create some extra negative bias, so that ground is actually a little bit above this potential here, so that this is like this point here is a little bit negative with respect to ground, and then that's used for good biasing, I believe. The resistors that I unsoldered for these blocks, this one, this one, this one, this one, and this one, I checked all the resistances, they all seemed fine, except for this one here, which measured completely open, so I replaced it with this little guy right here. It's 10k ohm. I'm not sure what the wattage was on this one, but I happen to have this 3 watt one, so that's what I went with. But all the other resistors that I checked looked okay. This one I didn't check because I didn't mess with that one, but this one also looks okay. This is a big Y around one. That looks okay too. So put the new cord in. Hopefully everything here should be good. We'll clean this mess up and then see if it works. Okay, so I'm going to plug it in now, and we'll see what happens. Nothing exploded yet. Let's turn it on. Light bulb's not lighting up, but it could just be dead. Oh, I see this tube lighting up. This is the 42, I believe. Rectifier is lighting up. So it has some arcing inside the. Can you see that? Alright, I'm going to assume that tube is no good. Yeah, the dial light came on. Yeah, that probably tube must have gone gas. Yeah, I guess. The ghetto doesn't look that bad though. That's interesting. Let's pull it out. See, the ghetto here looks fine. Not quite sure what's going on in there. Unless it got damaged by vibration or something. Maybe one of the grids came loose. Doesn't sound particularly rattly though. Does seem to be some of the oxide missing from the cathode. I wonder if maybe a piece of the oxide from the cathode came off and got stuck between the grid. Clean the top off now. See if any oxide comes down. Maybe one piece. Oh yeah. I'm not sure if you can see all the oxide in there. Oh, a piece of mica too. You can see right at the tip of the bulb there, that white clump there. So I'm not sure if that's all oxide, or the oxide obviously came from the cathode. There's something in there that has oxide on it. What I can do is try it again, see if we knocked, if it was a piece of oxide maybe that shorted it out, see if we knocked it loose or not. Obviously that tube is not going to be very good. No, it's still. Yeah, I better not do that too long. I don't want to fry anything. Okay, so next step is new. This is a type 42. Didn't see a number on it. Philco. Yeah, it's probably the original tube that says Philco on it. There's 42, yeah. So we need to order a new 42 tube, and after that, hopefully we can continue. Yeah, that's gonna got it for now. Just gotta order that tube, and I don't have a spare one of these, so order that tube, and then hopefully it'll work. Okay, so I'm getting much farther into this than I anticipated. I turned the chassis up on its side to check voltages on this tube just to make sure that, you know, something wasn't shorted and, delivering 100 volts to the grid or something, see if that was causing the arcing. I did notice that this resistor was pretty close to this wire. I'm not sure if they were touching or not, but this is painted, so I don't know if that would cause it or not. But I moved this resistor away and then checked the voltage. It is a bit high. I think it called for 2 volts on the grid, and this had closer to 11. That could also be because the tube is messed up. But anyway, when it was on its side, it stopped arcing, so I started playing with this radio a little bit more. And I was able to get some stations, but they weren't clear, and it seemed like almost all of them, one station was overriding another one, so there was no like single stations. Every station that I could tune in was like tuning in 2 or 3 stations at the same time. So I went back to taking a look at this, and it looks like someone has played around with this before. You can see this is not factory wire, taped to a factory wire, going over to a strand off the volume control. And I think nothing was attached here. There was a glob of solder here, but I don't think anything was attached to that one. And then there was a wire floating around randomly. And my best guess as to what happened here is the antenna coil went open, and in this radio the volume is controlled by adding resistance to the antenna. So this volume control resistor just adds resistance between the antenna coming in and the signal from the antenna going into the antenna coil. That's how it's supposed to work anyway. That was not working. I just put this wire in. I put this wire in where they had the antenna wire going up to the switch here. I'm not sure if that's the right place for it. But this has all been messed up. So my best theory is the antenna coil went open and they just tried to skip that stage of the radio by feeding the antenna directly into the oscillator, is kind of what it looks like. That's not going to work because on super heterodynes you need the antenna filter to filter out images. The way the super heterodyne works, if you don't have that filter on the end, then on the front end, then it's possible that multiple different stations will both mix to the IF, and then you'll get 2 stations tuned at the same time, which is what I was getting, potentially. Potentially you get 2 stations tuned at the same time. But basically, the way that the super heterodyne works is it mixes the antenna signal with a known oscillator, which you adjust by tuning the tuning capacitor, adjusts the oscillator frequency, and those 2 mix together to produce the sum and the difference. And when either the sum or the difference lines up with the IF frequency, then it gets through and you hear that station. But it is possible for multiple different stations, say that, oscillator plus antenna input equals IF, and then for a different station at that same oscillator frequency, oscillator or antenna minus oscillator equals IF, then you get those 2 stations tuned in at the same time. So that's why you always see the antenna RF filter on super heterodyne radios. That's why there's always at least two sections in the capacitor, because one is adjusting the oscillator frequency and one is adjusting the antenna filter, so that it ensures you only get 1 station at a time. And in this case, it looks like they had bypassed the antenna filter completely, is my guess. I'm not sure how they thought the volume control would work. I'm not sure whether there's an issue with the volume control or an issue with the way that they wired it, but when I was playing with it here, it looks like you only have volume at the very bottom of the volume control, and if you turn it up, the volume goes away. So I'm not sure whether that's an issue with the volume control itself, or just that the way they hacked this in here is 100% wrong. So anyway, I took the antenna coil out. You can kind of see the hole there. There it is. And in fact, the lower winding here was open. I unwound it, and it came off in, I think, at least 3 pieces. There was one big piece. Actually, I can show you what I have here. My mess. There was one big piece, and then here was a piece. There was a piece, and then there was a piece, and there might be one more piece. I just knocked it over. But I have confirmed that the remaining coil, this coil is good. You kind of see some brown spots there, and it looks like what happened was, focus, looks like what happened was it got corroded or something. It shouldn't have gotten hot because there's no current running through this, but I did notice some corrosion on it, so I think that the wax seal was not sufficient and corrosion got into it. You kind of see on that black spot, looks like the coil underneath has also gotten black too, so I'm not quite sure whether that's some kind of mold or what exactly happened there. But like I said, there should be no current flowing through that coil, so I don't know why it would have gone open or would have like burned open, unless their house got struck by lightning or something. That could theoretically do it, although I think the one that went open, the one that went open is the one that's connected off the antenna, so maybe the house got struck by lightning or something. Not sure. Anyway, at any rate, it has to be replaced. So I tried counting with my eye, and I counted 18 tones on the little coil, and then as I took it off, I counted each tone and I counted 21. So that's going to put the discrepancy down to the fact that my eyes aren't microscopes, and go with a 21. Even if that is 1 or 2 tones off, hopefully I should be able to compensate for that with the RF trimmer capacitor. But either way, a coil in this position will be better than no coil in this position, which is what we have now. So I'm going to use this magnet wire. This is a little bit thicker than what they use, but it's the thinnest that I have, so we're just going to go with it. Should be okay. See if I can. I don't know if the camera will get close enough for this, but you can definitely see that the top one is much thinner. The top one is much thinner, so this coil is going to take up more space, but hopefully it'll be okay. So I'm going to work on winding this, and then I'm going to have to figure out what this is, where this wire is supposed to go to, because this is a factory wire. It looks like they cut it off somewhere and attached it to this, which is not correct. So I'm going to figure out where this one originally, and then reconnect the volume control up the way that it's supposed to be, and hopefully then it will work. Okay, so I reinstalled the antenna coil, started out the radio again, and got absolutely nothing. So then I went to investigating other coils, and I found out that the oscillator coil, this coil here, focus, this coil here was also open. So I've unwrapped that one, I've got to rewind that one. I did check the remaining IF transformer coil here, and got some confusing results. I'll say confusing because the schematic is also confusing in this area. Let me pull this up here. So let's see. So this is the oscillator coil here, and the part that's broken is this 3.9 ohm one down here. And what that does is these two here are the oscillator, and then this one couples the oscillator signal back into this tube through the cathode. At least that's what it looks like to me anyway. You see this cathode resistor here with a capacitor across it. I believe that you can see here's the tuning circuit, the coil, and the capacitor there, the tuning capacitor. That's the tuned oscillator circuit. This looks like a feedback from the oscillator to keep it running. So basically, the oscillator gets kind of like a bump probably when the radio starts, and then this coil and this capacitor are going to oscillate at the desired frequency, and then that couples through this coil back into the tube, which amplifies that, and then that amplification shows up here on this line, which is then coupled back into the oscillator through this coil to keep the oscillator running. And this coil is open. So without that coil, there's no way for the oscillator to couple back into the tube to amplify and keep the oscillator running. So I can't imagine that the oscillator would run at all with this coil open. And it looks like the mystery wire that they had connected to the volume control was actually this wire here that goes to this capacitor labeled A, and that comes down and connects to the cathode side of the cathode bypass resistor. So it looks like they set up the volume control to control the cathode bias of this tube. And that would explain why it was loudest when the volume control was at its minimum, because when the volume control is at its minimum, you're basically shorting the cathode of this to ground, which would give the maximum grid bias, which would bias the tube on the hardest and provide the most gain. Also potentially could cook the tube if you're giving too much grid bias, so that tube may need to be replaced. Anyway, so how this radio even received the signal at all is kind of a mystery to me. With no antenna filtering and no oscillator, basically it looks like they were, I think they had the antenna hooked up to the grid here. So basically they were just shoving the antenna signal directly into this grid and then hoping it would couple across to this tube. It's very strange. Anyway, I'm going to rewind this coil and hopefully it'll work. There were 18 turns on this coil. So I don't think it's super critical because if you notice there's no tremor across here. So I don't think the number of turns is exactly critical on this coil. If it was, they would have a tremor to get it exactly right. But I counted 18 turns, so that's what we're going to go with. And hopefully, after that, this video will work. Now, the interesting part that I mentioned earlier is this coil here. So everything checks out here, except for this top coil, which has no resistance reading. Now, the weird thing is, this resistor here, which is actually inside the coil can, is a 4 megohm resistor. Now, why you would put a low impedance coil across a 4 megohm resistor doesn't make any sense to me. So my best guess is that this coil here isn't actually supposed to be connected across the resistor, that this end is just open and it acts kind of like a pickup thing. I've seen this before in other radios where they just have a coil of wire where the other end's not connected to anything, and that just acts kind of like a pickup without actually being a coil, if that makes sense. So kind of like the coil, the wire's wrapped around the same core, but the other end is just open, not connected to anything, and just the magnetic flux through that open-ended coil is enough to couple the signal through. And why I say that makes sense here is because of this 4 megohm resistor. If you're going to connect a low impedance coil across a 4 megohm resistor, you may as well not even have the resistor because the coil is just going to short it out. So that's my best guess as to that. Actually, if we scroll up here to the type or the model 80 schematic instead of the 81, you'll notice they don't even have that coil. They just have a very low value capacitor connected across that resistor. So that makes sense then, that this coil here would not be connected. That's just in place of that capacitor, in theory. So I did check it. This coil is not connected to this point, even though it shows it here, but it doesn't show any resistance reading, and all the other coils do show resistance reading. So that further bolsters my theory. I'm not even showing the right thing. This coil here does not show resistance reading when all the other coils do, so that further bolsters my theory that this is not supposed to actually be connected to anything. But if we find out that it doesn't work, I can always fall back to this design and use a low value capacitor across that resistor and see if that makes any difference. But first I'm going to rewind that coil and see if we got anything then. Okay, so the oscillator coil has been reinstalled. Let's see if it'll work now. Do hear a little bit of static. I don't pick anything up though. Oh, I know why. We got to reconnect the grid cap one of the other coils. We have to resolder that back on. Okay, let's try that again. I had taken the plate cap off the wire coming out of this coil, the IF transformer, so I could take this coil out to inspect it. And I just forgot to solder it back on. So I've done that, put that back on, so now let's see what we get. Two look to be lit up. Well, there's something there.
This time of year, which was a scary statistic.
Well, the speaker doesn't sound too hot.
Wrong type of vitamin D.
Okay, so there's something up with the speaker rubbing, I guess. But it does seem to be working now.
When it comes to retirement, 855-742-2677. That's 855-742.
You could probably do with an alignment, especially after playing with those coils.
And here it is. You don't have to go to...
Clearly no AVC on this one.
Americans. But this thing, like...
Turn the volume back up and tune this.
An investment advisor representative.
I'll turn back to the top ending where most of the stations are. I have some nice ones in, the nice ones coming in, nice strong signal. Of course, I do have an antenna stretched halfway across my apartment for this, because I wasn't expecting this radio to be that sensitive, given that it only has 4 tubes and no IF. But we are getting pretty good volume, so I might try to go without that long antenna, just see what we get. But definitely have to adjust the speaker.
I think a lot of folks, that the harmful use. The cable, frankly, that's the very common and most popular thing.
The volume all the way down. There's some music. Okay, definitely have to adjust the speaker next. See if I can get the rubbing out of there. When I move it, doesn't really feel like it's rubbing, so maybe there's just some dirt or something down there that's vibrating. I'll take a look at that. But definitely satisfied with the reception now. It's definitely getting stations and certainly plenty of gains. So I'm going to consider rewrapping those coils a success. We'll probably have to play with the alignment a little bit, or we can just leave it as is because it definitely, is usable. Like there's definitely plenty of gain on a lot of those stations, so we'll see. But I'll probably play with it anyway just because. So yeah, let's take a look at this speaker, see if we can find out what the deal is there. So it sounds a little bit better, I think, but there's still something wrong here. Something's rattling inside. I don't know if you can see, but I took a razor and I cut all the way around the outside to cut the cone out to take it out. And I couldn't find anything that looked like it would be loose or rattling in there, which is what it sounds like is happening. So I put it back in, and it might be a little bit, but I don't know, it doesn't really make sense. It sounds like something is loose and rattling, resonating in here at certain frequencies, but I can't find anything that seems to be loose, so I'm not quite sure what's going on there. Anyway, I think I'm going to call this part 1 for this radio. I'm going to replace all the tubes in here with the sparking in the output tube, which seems to have gone away, but I'm sure that damaged the tube somewhat. And the fact that they had the tube bias completely wrong on the 177, so that one is probably not as good as it could be if they ran their life down by biasing it wrong. So I'm just going to replace all the tubes in here just to eliminate that as an issue. Hopefully assuming the tubes that I get are good, because any tubes that I get are obviously going to be 60, 70, 80 years old as well. So hopefully I can eliminate any tube problems by replacing all the tubes, just to get that out of the way. There's only 4 tubes in here, so I don't think they're particularly expensive tubes. So let's go over what was wrong with this radio. I'll pull the schematic in here. And before we go over what's wrong with the radio, let's go through what's wrong with the bendy pad, because you can see on this page I took some notes. And I had actually taken some more notes. I wrote down the number of turns of each of those coils that I rewound, and as you can see, I'll back you up anyway, as you can see, those notes are no longer there. So at some point when the screen blacked out, it erased the notes that I had taken. So that's kind of stupid, considering that's one of the main use cases Apple plugs this for, is note taking, and it can't even do that properly. Anyway, let's go over what was wrong with this radio. So the first issue was the open coils. So this coil here, the antenna input coil, was open, and this coil here, the oscillator feedback coil, was also open. So and that was the main issue. Obviously electrolytic capacitors, which were these two guys down here, I'm sure were bad. So, I mean, one of them was already replaced. So, replaced all the capacitors because they were in the Bakelite blocks, and then we rewound this coil and this coil. And what they had done to attempt to use this radio without those coils, which is very bizarre. I've never seen someone try to do that before, actually. To try and bypass the antenna and the oscillator coil and use the radio not as a superhead but as a TRF set, I guess. First time I've seen that. Anyway, they fed the antenna signal directly into the grid here, so bypassing this coil entirely, and then they connected this point here right off the cathode. They connected to the volume control resistor, a wiper, which then went to ground. So basically the volume control was then adjusting the grid bias of this tube. And of course, the closer, the more positive you make the grid. Now in this radio, they have the grids negative. You can see this resistor down here goes from ground to the center tap of the transformer. So that actually generates a negative voltage. The current flowing from ground through this resistor to the center tap causes a voltage drop across here. So this center tap line is actually, I think it's supposed to be like negative 5 volts or something. And then that line runs up and then biases all of the grids negative. So basically the way that they had this set up, they were either valuing the resistance of this cathode to ground, which would then make it this voltage go above ground or equal to ground when this wiper is at ground potential. Let me try and explain that better. As current flows through this tube, it flows from the anode to the cathode, and then down out this bias resistor through the coil to ground. They had just connected this line here right to the potentiometer wiper, so by varying the resistance here, you vary the voltage of this cathode because the current flowing through induces a voltage drop across this resistor. So when you turn the wiper all the way to ground, you've got this cathode voltage at ground. When you turn the volume control up, that increases this resistance, causes a voltage drop, raises the voltage here, which drives the tube forward towards cutoff, the higher the cathode voltage is. And the lower it is, the closer it gets to the grid voltage, which remember the grid is at negative 5 volts with respect to ground. The closer the cathode gets to the grid voltage, the more gain the tube has. So that's why I think the volume control is acting backwards, because I think when the volume control is low, it's close to ground, and as you turn it up, it drifts away from ground. But when they hooked it up here, the closer this wiper is to ground, the more gain this tube has, and that's why you got the most volume when the wiper was when the volume control was at its lowest point instead of at its highest point. So yeah, that's the two hacks that they did to bypass these two coils, and yeah, very strange. Anyway, so that's going to be part 1 for this video. We still have to replace all the tubes and figure out what's going on with the speaker. And I can't figure it out, I might just replace this speaker. This is a deep dish speaker, so I can probably, if I take the cone out, I can probably get a small speaker to sit right in here in place of the cone. Maybe do that. I don't really want to do that because I think these old style speakers with the field coils are pretty cool. But if I can't figure out why it's having this resonance, I'll have to do that. Obviously you can't just eliminate this entirely because you need the field coil and the output transformer in order for the radio to work properly. So if I can't figure out what's wrong with this, I'll just remove the cone and then set a new speaker inside here and just hook it up to the output transformer leads. But hopefully we won't have to do that. Hopefully I can get this one working pretty good. So there is still some distortion, and I'm pretty confident that's due to the tubes being messed up. I checked the grid voltage again on the output tube, and it's measuring 15 volts now, and it should be like 2. So, and that voltage is controlled solely by this resistor, which I have measured this resistor, and that measures fine. The cathode of that tube is connected directly to ground, and the grid of that tube is connected directly to, well, not directly, through a resistor to the opposite side of this point. And the voltage drop across this resistor is 15 volts. And according to what I'm reading, that should only be like 2 volts. So there's definitely something going on here. It could be that, you know, maybe that tube is partially shorted or something and conducting more than it should, which is causing a higher voltage drop across this resistor. But anyway, we'll figure all that out, hopefully figure it out in the next video. For now, we did get this playing. Not really well, but it is playing.
Investor. Okay. Now, why is that important?
You can hear that resonance again.
It doesn't really matter, but I think we can all agree.
Ooh, that's too loud. You can hear that it sounds like there's something resonant in there, but like I said, I can't find anything that would be loose enough to resonate like that, so that's really strange. Anyway, I hope you enjoyed this video. Definitely a lot more work on this video than I was expecting, but hopefully we'll get everything sorted out in the next part. Thank you for watching.